What's up, guys? Enderunknown here. I'm back for episode 4 of our Unity Spelunky-Style game series. Hooray! And today we are going to actually be working on a couple of fixes to some of my previous stuff and also the player. So we are going to start the player today, which will be interesting. I decided to do it a little earlier because it doesn't make sense to generate gold and add enemies if we can't even have a player to explore our map in. And also a lot of the stuff is, uh, I don't know, like, it doesn't make sense to make gold in our entrances and exits when they can't interact with the player. It would make more sense to have the player in place and then have those items interact with it, at least to me. Anyways, a couple things I did is I selected all of my assets and I set their Z position to 0 except for the camera, which should be at -5. And then, yeah, so I noticed I misspelled border. I was probably in a hurry when I was making that last episode, so I am sorry uh, about that. But hopefully, yeah, it's BOARD, so border, as in a snowboarder or something like that. Anyways, that's not relevant. Now, sorting layer, everything's currently on default, but our background has got a order and layer of -1, and each of these little border tiles should be 0, and the main camera doesn't care about that, and the generator doesn't care about that. Anyways, yeah, so that is pretty much all that we needed to change, and I'm trying to think of anything else. So, yeah, I think we're going to get straight into making our player. So for, I guess, ease of later access, I'm going to go down to our sprites. I'm going to grab the axe. I know that sounds a little odd. And we are going to be making this our player. We will change the texture later, but for the time being, yeah, we're using an axe. I know that's very silly. So, yeah, today we're just going to be working on player movement, animation, and getting the level system and all that stuff to work in the game is going to be for a later episode. Today it's just making the player move. So to do that, we have our little X sprite here. Um, we need to add some components like a 2D rigid body. This is going to be set to kinematic because we are going to be programmatically controlling all of our um, movement. We're also going to want to freeze the rotation. This was funny playing around with the axe when I was testing some stuff out, as it would just keep spinning and spinning and spinning. Anyways, we are also going to want a 2D box collider, and this is going to need some adjustment, because right now this is the size of a tile. We want it just smaller than the size of a tile, because otherwise it gets stuck. Uh, Now we'll, of course, readjust this for the actual player, but yeah, who's not as big as a tile. The X was made in the same size. Anyways, that doesn't really matter too much right now. And we are going to quickly move on to our sprites after our sorting layer is going to be 1. Order and sorting layer is going to be 1. So we're going to go back to our scripts and create a player motor. And we are also going to create a player controller and then open both of those up in Visual Studio. So I'll be back when these are open. Okay, now that it is loaded, we are going to be starting with the player controller. I don't have too much time, so I'm going to get right into it. So yes, we are going to make a public float called ground normal y. I'm just going to be declaring a bunch of variables that might not make a bunch of sense here now, but they will make more sense when we actually start working with the player motor. So basically the player motor is going to extend this. So it applies small changes and in fact is what actually moves the player based on the physics math that we have in this controller. So yeah, this controller actually could be the basis of movement for other things as well. So maybe it was not a great naming convention for me to call it player controller when maybe it should have just been controller base. Anyways, yes, I'm just working on adding considerable amount of these different math stuff. I'm not going to So I guess I will do that. So basically defined a bunch of variables that we're going to need, and we are getting the uh, rigid body reference here, and now we are setting up this contact filter, which I believe helps us with our collision. So we're going to set use triggers to false. We're going to set set layer mask physics 2d dot get layer collision mask game object layer. So it's going to get its own layer, and then we're going to use the layer mask. That's going to be true. So that's all we need for start. In update, we are going to start with our getting some velocity stuff. So our target velocity variable is going to equal vector2 dot 0, which is the shorthand way of writing, well, it says here in the little note here, just a 0, 0 vector. And then we are going to be using a method that we have to create called compute velocity. And yeah, so this is going to be overridden by our player motor that extends it. So computing the velocity is up to the player, and that is why we have a virtual void, so it's easy for overwriting it. Anyways, we're just going to move on to the actual physics math. Update. There we go. So fixed update is where all of Unity's physics are supposed to be handled. So this is what we're going to be doing with our gravity modifier. Gravity multiplied by time, delta time. Essentially, this is going to be applying a gravity force to the player. And our x is going to move based on our target velocity's x, which is going to be set up when we are computing velocity, but we do that in the player motor. We also have our grounded value that is going to equal false. It will be set accordingly. So the delta, or change in position, is going to equal the velocity multiplied by the time, the change in time, or delta. We're going to want a move along ground. It's going to equal a new vector 2 ground normal y, and the opposite of ground normal x. And we are also going to want just a normal move, and that's going to move along ground times time dot delta. Oh, no. Sorry. Delta position x. So our change in position, we're going to move along the ground based on the change in our position on the x-axis. So we are going to also, we're going to do move is equal to vector 2 up, which is shorthand for, well, again, in the little prompt pops up before I talk even. So yeah, 0, 1. And we are going to multiply that by the change in delta position y. Surrounding that, we are going to be making a new movement method here, function. And it's going to take in the vector 2 for move, and also a boolean contemplating if we are worried about our y movement. So yeah, we're just going to create that here. Vector 2 move bool y movement. So inside of this, we're going to need a distance float, and that is going to equal the magnitude of our movement here. If distance is greater than our min movement distance, so basically the min movement distance prevents us from nearly infinitely moving in infinitesimal small distance. So essentially it's just debugging stuff. I think that causes problems. Anyways, we're going to make a integer called count, and that's going to equal the rigid body 2D when it's cast using move, our contact filter, our hit buffer, and our distance plus our shell radius. We're going to clear our hit buffer list so that we can add to it here. So for I, or for loop, while I is less than count, we are going to do hit buffer dot, or list dot add hit buffer at index I. I stands for index, that's why they iterate through I. Back when I think coding was relatively a new thing in computers, that you could program, where unlike the Don Horizon, you could only use one letter for defining variables, I believe. So they just abbreviated I for index, because that's what it does. It indexes through things. Just a fun fact there. We're going to then move through our hit buffer list like count. So vector 2 current normal is equal to our hit buffer list I normal, and if our current normal y is greater than our minimum ground normal y, which means, again, it's one of those threshold things, Then grounded is going to equal true, and if y movement, in other words, we are calculating our using our y-axis, that's going to equal current normal, and current normal dot x is going to equal 0. So we're almost done here with our player controller thingy. So yeah, we're gonna get the dot product here using our velocity and current normal. That's gonna equal our projection, and then using our projection as kind of like a meter if it's less than 0, then we are going to adjust our velocity appropriately. So velocity minus projection multiplied by current normal, and then finally float modified distance equals hit buffer list I distance minus shell radius. And of course distance is going to equal our modified distance, only though if it's less than the normal distance. So this is like an inline Boolean statement or if statement. So modified distance or distance. So essentially, if the modified distance is less than the distance, if that is true, it'll use the modified distance. Otherwise, it'll use the normal distance. Anyways, that's just an interesting thing. Finally, we're going to use the rigid body's position, and we're going to set that equal to the position plus move, and we're going to normalize that and then multiply it by distance. So yeah, that was a mouthful, but this is our player controller, and that is all wrapped up. I'm going to go into the player motor script here, and we will start up there in just a second. Okay, now in player motor is actually going to extend our player controller, and we're going to get rid of these. And yeah, so pretty much what we're going to need to do is make a integer called player speed, and we're going to also need another integer for player jump height. So basically those are self-explanatory. We're also going to need a boolean, so private bool for facing right, that's going to equal true. And so yeah, this is gonna have to do with our animation stuff or making the sprite make sense. I don't know if we're gonna do that in today's video. We'll see. I'll have to see how long it is. I'm guessing probably not. I think we'll move on and work on like making the sprite look nice for next week's video. Anyways, yep, enough of me dilly-dallying. We are going to need a start method, and inside of start we are going to set our I'm used to doing this in just programmatically having to set things, but the Unity inspector is nice, so I guess we don't have to set player speed or jump height. I don't know, that's just weird to me. Update. Anyway, so yeah, in our update method we are going to do update player, and this is essentially, oops, silly me. We're gonna make a new method called update player. Okay. So our gravity modifier also could be set in the Unity thingy. So why am I modifying it? I don't know. Float our player speed is going to equal, or p speed actually, input dot get axis, and we're going to do horizontal, and then we are going to get our vector2 move, and that's going to equal vector2 dot 0. We are going to be, of course, changing this. And then now here's kind of our input. So a little further down, if we are crouched, or so if crouched is equal to false, and we are not pressing the key left control, which I believe is the crouch key, our movement x is going to equal input dot get axis, because for sake of time, horizontal is a long word to type out, so I'll copy and paste it. Then else if crouched is going to equal false, and, or actually, so crouch, there we go, that's a nicer way to put it. Input dot get key, oops, I'm very tired and this is not working. Okay, there we go, left control. Okay, then we're going to do, so yeah, this is sprint. Input get axis, there we go. Horizontal. And we're going to want to actually multiply that by 2, or I guess you could make a variable to control that. So, yeah, because multiplying the speed by 2 is maybe a bit much for sprint. If we are get button down for our jump, and if we are grounded, then we are going to do some more checking. So if our math, the absolute value of our velocity x is greater than 0, velocity y is going to equal player jump height plus the absolute value of our velocity, our x velocity, multiplied by 0.2f. Okay, and then otherwise, or else, our velocity y is going to equal player jump height. So we're going to continue on here to if we're getting the jump button, which is spacebar, pretty much. I think you can set it in Unity. If our velocity y is greater than 0, then our velocity y is going to times equal 0.5f. I believe you can do that with vectors. Otherwise, if it is not, or if none of these are being pressed, crouch is going to equal false, and we'll have some stuff to do with animations later on. Yeah, so then we are just going to be, if our x movement is greater than 0, then facing right is going to equal false. And so yeah, we are going to do Boolean. Well, actually, no, we're going to do this later when we do the player texture or sprite or whatever. So yeah, we'll do this later. That's code still all proper. We're going to use that. We're just not going to do it right now. Yeah, so then I think all we need to do is target velocity equals move multiplied by player speed, and that is absolutely all that we have to do for our players. So I'm going to go back into Unity and we are going to set it up. Okay, now that we are back in Unity, we're going to click on the player. And actually, one thing we want to do is drag the camera onto the player and then zero out the X and Y coordinates of the camera so that it is focused on the player there. Um, we'll adjust the camera size as necessary later on. So yeah, we are going to add our player motor script on here. Our gravity modifier is going to be 5. Our speed is going to be 10. And for the sake of exploring, our jump height is going to be 50. Because why not? And I'm going to save and press run. So yeah, we can now move about in our scene. And as you can see, we jump profusely high. So yeah, some of that code. In fact, we probably want to maybe make speed a little higher. I don't know. I like having a high jump height early on so that we can explore with ease. I'm going to go adjust those values. I think maybe player speed was supposed to be 50 and jump height was supposed to be 10. I don't know. Well, that's not right. I'm stuck in this pit. I don't know. You guys will have to play around with these values. I think okay, maybe it was this. 10, 20, 30, I don't know. I'll have good values for like the actual game. And maybe this is fast enough. I think the camera just needs to be zoomed in a little more. It just feels slow. But yeah, so now we can actually explore our map here, which is really nice. And yeah, so this controller, as interesting and possibly confusing as it may be for setting up in Unity, it is really nice. I've noticed, like, I was working on a different controller earlier today and it kept sticking to all the tiles and walls. It looks like I'm sticking, but that's just me jumping and getting caught on things, because squares. But overall, like, I can't do the wall cling, which was a problem I had with the last one, is that I just get stuck in the wall since these are multiple colliders. So yeah, this is a seemingly high quality uh whatchamacallit controller. So I guess realistically our jump height will probably be like 10. Well, actually no, not 10. 20? Yeah, it'll probably be like 20. So that jumping's possible. So we can jump oop, we can jump up places, but if we had to get up back up there, we'd need a rope or whatever. So I should be able to get on top of that, yeah. If I hold space and move properly, I should be able to get on top of most of these things. But I'm not able to actually reach up onto the top. I don't know. You guys will have to play around with it. I'll play around with it, and I will update these controls accordingly. But yeah, that is all that I have today for you guys. I guess as a final note, I would like to apologize for me kind of seeming tired and out of it today. I just haven't been feeling like doing much, particularly today, and I don't know. I hope it didn't show too much in my video if I was a little bit cranky or whatever. Anyways, I'm hoping for a regeneration in energy for next week as we move on to some of the more exciting parts that hopefully I'll be able to explain a little better, such as player animation and whatnot. Anyways, thank you guys for watching. I will be back next week with another video. Ender out.